Okay, hello. This is session 12 of our basic Python course called Data Visualization. And today we're having a look at a few packages that exist in Python for plotting data. Because other than for numerical analysis, where we have NumPy, and for scientific computing, where we have SciPy, and for data analysis, where we have pandas, there is no broad consensus for what the best package is when it comes to data visualization in Python. And instead, there exist a few packages, um, which we will have a look at today. And we will briefly review what the pros and cons of these packages are. So first, there's matplotlib, which we already encountered in our session on array computing. Then there's pandas. Pandas does not only offer tools for reading data from files and manipulating it, but also for plotting. And we got to know pandas in our last session on data analysis. And today we will see what it has to offer for visualizing data. And then there are two other packages called Seaborn, which is another quite popular one, and Bokeh, which allows for interactive visualization of data. Okay, so I'm switching to Spider, and here I have opened the script rotation that we wrote in our session on array computing when we were trying out matrices and vectors and used coordinate rotation as our example. So I've reopened the script because here we already have the basic ingredients of plotting with matplotlib. So we're typically importing a submodule from matplotlib, here pyplot, and we abbreviate it as PLT in order to make commands a bit shorter. And then this PLT module offers a few types of plots. For example, scatter, which supposedly creates a scatter plot, and to which we only need to supply X values and Y values, which are plotted against each other. And then we added two further commands for plotting a vertical line and a horizontal line using the commands XV line and XH line, which we did in order to emulate the axes of our coordinate system and to see where the origin is. And then at the end of a matplotlib section, you typically write plot show so that the plot that you have prepared with the previous command is also actually displayed. So if I'm running the script, I get an output, and depending on how your Spider IDE is configured, you may see separate window in which this figure is opened, or you might see this figure open in the top right tab here, where you can select between plots and files and the variables. And on the plots panel, there now is the figure that we have just created. So I'm going to enlarge this a bit in order to better see it. And if you prefer having figures as separate windows, which is, for example, more common in MATLAB, you can also undock this window. I'm going to leave it here. And then there are a few quick tools that you can use. For example, you can navigate through plots if there's multiple in them here. We will see this in a minute. You can save them as files, and you can also remove all the existing plots if you want to start new and fresh. Okay, so with that, I want to extend our matplotlib knowledge a bit by having a look at the penguin data and producing a scatter plot for the penguin data. So here I'm importing pandas and then read the data frame penguins from the penguins file, which we already did last session. And we know that it has 4 columns and there's 125 observations. And we have stored this as tabular data. And here I'm again calling scatter command from the pyplot module, and observe that this time as x and y values, I don't give it vectors, but I give it columns from data frames. So we know that if we are accessing a data frame and we are indexing it using a column name, then we get another data frame consisting just of this column. And it turns out that we can also use this as input to matplotlib, which is very nice. Additionally, I was here using the command figure, and figure serves to open different figures. So you can, by this, have different plots and different figures without necessarily overwriting previous figure. And this is usually done by providing an index in Python numbering starting from 0 to all the figures that you open. So later we will have a second figure called figure 1. Okay, so if I'm running the script, we see a plot of depth of each dive for all the penguins against the duration of each dive. Might notice that there are no X and Y labels here. So if we want to have them, we have to explicitly state that we want to have X and Y labels, and we would have to provide strings with whatever we want to have as our label on the X and Y axis. So I'm here writing duration to the x-axis and depth to the y-axis, and I'm also providing the units of those measurements, which is typically considered good practice in data visualization. So if I run this, notice that now a new plot has opened here, so I can navigate through these. And this is the most recent plot that I've created, where I now also have axis labels. Okay, if we take a closer look at the dots in this scatter plot, we see that there seem to be outliers on top here. So generally, there's a weak linear relationship between duration and depth, which is plausible because the longer a penguin is diving, the deeper it can get. But then there are data points in which a very, very large depth is reached with only some kind of medium duration. So if we take a closer look into the data frame, we would notice that those dives are, most of these dives are coming from a single penguin called EP3109. And our goal now is to separately plot the dive from this penguin from the dives of our other penguins. So what we do in order to achieve this, we first write the penguin name or label into a variable, and then we form 2 groups by taking subsets from the penguins data frame. In one of the group, we are collecting all the dives from this particular penguin, which is here referred to as group 2. So we do this by logical indexing and only taking these rows from the data frame where the entry in the column bird is equal to our favorite penguin. And then we do the inverse of this. So we take all the dives for which the entry in the column bird is not equal to our favorite penguin. So this gives us 2 groups of dives, and we can plot both of them by just opening two scatter plots and again plotting depth against duration by providing them as x and y values to scatter. So if I run this, the output looks like this. And here we can see that those dives here in the upper right corner mostly come from our favorite penguin. So Matplotlib has now, by default, used different colors for the two scatter plots that we have inserted into the axis. Okay, once again, we could, of course, add X and Y labels, but I leave it at this by now. So to sum up, the advantage about Matplotlib is that it gives you the most detailed control of the features of the figure. So in principle, you can determine every little detail of the plot. However, the disadvantage then is that everything which is non-default must be explicitly specified. So you will have to add another command for each little detail that you want to have different than what you see or what is produced by Matplotlib's default values. And this can make Matplotlib code very long. On the other hand, if you're coming from MATLAB, much of the code will probably look familiar to you as the structure of controlling plot details is similar. Okay, so with that, I want to turn to pandas for plotting. And before I do this, I want to have another look at the pandas data frame. Let me see whether it's still in the working space. Okay, so this is the penguin data frame. And if I type dear penguins, I see all the methods that are applicable to this variable or data frame. And we can, for example, see that there is a submethod called plot. So let's deal this again. And if we ask what methods or functions are available in Penguin's plot, we see that there are, again, a lot of behind the scenes operation starting with double underscore, which we don't need to worry about. And then there are a few words which might seem familiar to you because they are describing plot types. So I can also display those by running this little script here. So, for example, we see scatter, which supposedly creates a scatter plot, just like in Matplotlib. Then there's pi, probably for pie chart, which the type of plot which divides some kind of totality into its segments. Then there's histogram and bar plots and horizontal bar plots. And we now want to have a look at just a few of those. But before I do this, I want to introduce a brief abbreviation into our script. So in this plotting example from Matplotlib, I was loading the penguins dataset. And in order to do this, I always have to write these three commands: importing pandas, specifying the file name, and reading from the CSV. Now, I have transferred these three commands to a separate script. And given what we have learned in the section on modules, we know that each script can also be run as a module. So if I type import load data, that's the name of the script, I get a module that is called load data. And this module will have an entry called penguins because all the functions and variables that are defined inside a script are available in the namespace of the module when the script is imported as a module. So in other words, I could now refer to penguins from here on in this way by just writing load data.penguins. Or I could take this variable from the namespace load data and write it into the main workspace variable name penguins. An even more elegant solution to this is, of course, to only import this single variable when importing the script as a module. So from load data, import penguins. If I write this line, I have the data frame penguins in the main workspace. And this is what I'm going to add now to all the following plotting scripts. So here in plot pandas, I now have a line which says from load data import penguins, and this allows me to save me a few lines of code, which otherwise I would always have to repeat when opening a new plotting script. Okay, so now we saw that each data frame in pandas has a subsection called plot, and in this subsection there are a couple of methods for plotting, among them scatter. How does scatter work? So basically it's very easy. You have already specified the data frame from which to take the data because you're applying a method to this data frame, which means that in brackets, you don't have to provide the x and y coordinates of your scatter points as vectors, but you can simply provide the column names from which you want to take these x and y values. And at this point, you need to pick the column names that are used in the data frame. So once again, we want to plot depth against duration. So run this section of code, and we again get a plot of depth against duration. Observe that now I am provided with axis labels despite not explicitly specifying them. This is because I'm plotting directly from the data frame, and I have supplied the column names which I want to use as x, y in my plotting command. So the pandas default is taking those column titles and adds them as x and y labels here. If I want to change this, maybe because I don't like the labels, I have to explicitly specify the axis commands. And for this, you can once again use matplotlib commands. So I'm still importing matplotlib here. And if I want to have the x and y labels differently, I'm adding commands for that. So with that, I have basically reached the exact same plot as before that I was creating with matplotlib. Okay, so just to let you know that there are also other types of plots. I'm trying out a few other ones. I'm trying out a few other methods from the plot section of a data frame now. For example, there exists a method called bar in which you also specify x and y by a keyword argument. And what you would then get is that the values in the y column will be used to control the height of the bars, whereas the entries in the x column will be used to label the plot. um, on the x-axis. You can also do this the other way around, that is by having um, the labels on the y-axis and the bar lengths on the x-axis if you want. For this, you need to take bar h for horizontal bar plot, in which case the plot will look like this. This is probably not the best way of looking at those data or representing those data because yeah, we cannot even see the labels here. And it's very hard to make out from this how the penguins are differing in terms of their medium dive duration or depth, for example. Okay, and at last, there is a function for preparing a histogram, which is called hist. And in order to do this, you only need to create a subselection from your data frame by naming a certain column, in this case duration, and then call the hist message from the plotting section, in which case you get such a plot. So this is a plot which is separating the, in this case, durations into several bins. These are showing on the x-axis, and then for each bin you are provided with the number of observations which fall into this bin. You can also control the boundaries of the bins. So for histogram, there's a keyword argument called bins, and you can either let this be a number, an integer, which will then be the number of bins, or it can also be a list, in which case all the list entries are taken as bin boundaries, and each bin corresponds to the space or the range between two successive values. We will here use bins of size 1 by creating a range object. Let's use all the numbers from 0 up to, but not including 21. So this will be all the numbers from 0 to 20 in steps of 1. And I'm converting this to a list. And if I run this, I get bins of size 1. So you can now see that the bins have gotten narrower because I was modifying the bin sizes to so that each bin width is exactly equal to 1, which maybe gives us a more precise look at the data set than before. Okay, so these were a few other examples plotting from pandas. To summarize, pandas is very great in the sense that you can create the figure directly from the data frame that you have loaded with pandas. And in principle, there's no other module needed for creating the plot. Unless, of course, you want to modify the plot a little bit, in which case you need matplotlib command. The disadvantage of pandas is that it can only produce very few basic types of figures, and if you want to do something more advanced, you then have to resort to something else again, probably. Okay, one package that is a bit more advanced is Seaborn. So I'm switching to my example script for Seaborn, and Seaborn also has one function devoted to scatter plots, which is called scatterplot. And the syntax between pandas and Seaborn is a bit different. So whereas in pandas, you are applying the plotting commands directly to the data frame, we here have functions from the Seaborn package, which take the data frame as an input argument. So you always have to use the keyword argument data in order to specify the data frame from which values are taken. And then the X and Y notation is similar to pandas. So you're simply naming columns coming from this data frame. So if I run the script, I should get a plot. Okay, sorry for the glitch. I need to update my Seaborn package, and now I'm back in the recording. And if I run the script, I get this output. So once again, because Seaborn and pandas are using matplotlib in the background, we get a very similar plot here, and similar to pandas, Seaborn also adds default axis labels. So if I want to change these, I have to use explicit matplotlib or pyplot commands in order to achieve this. Okay, so I want to now change two slight modifications to the Seaborn scatterplot command, which show how further manipulation of the scatterplots can be done. So the first example will be coloring the dots in order to distinguish the different birds or penguins. So I'm opening a new figure, and I'm again showing a scatter plot using the same configurations as before, but now we have a new keyword argument, which is called U, and it's set to bird. So this command as a whole means take the data frame penguins, plot the values in the column depth against the values in the column duration, and use the labels in the column bird in order to distinguish the color of the dots. So we know that bird is not a continuous variable, but it's a discrete variable which has a set of distinct values, namely the penguin labels. And what this command will do, it will color all the dots according to their identity in the column bird. So this is how the command then looks like. You also get a nice legend telling you which bird is which. So you get as many colors here as you have different entries in the bird column. Okay, another thing that we want to try is coloring, not coloring the dots, but modifying the size of the dots. And for that, there's another keyword argument in scatterplot, which is called size. So this command here would mean take the data frame penguins, then do a scatterplot of depth against duration, and use the entries in the column heart rate in order to control the size of the dots. So if we run the script, we get the following output. So this looks very similar to what we had before because it's the same data set and in principle the same plot, but observe that now the plots, the dots have changed their size, and the size behaves according to the heart rate in each individual dive. For this, you also get a nice legend, so you can see that dives in which a higher heart rate or average heart rate was obtained get larger dots, and those with lower heart rate get smaller dots. Here you can already also spot some interesting relationship, namely that um, relatively short dives and not very deep dives are accompanied by very high heart rate, whereas um, as dives become longer and deeper, the heart rate is decreasing. A potential explanation for this could be that um, the penguins or the organism is lowering the heart rate in order to save oxygen or to reduce the oxygen consumption, which then allows for longer or deeper dives. Okay, so this was it for Seaborn. To sum up, the advantage of Seaborn is that it is fairly easy to use. You can relatively quickly create a very complicated figure. There's also a large example gallery which you can check out, and where you can also see the code for each example. The disadvantage is that if the function for a desired figure is unavailable, then adapting Seaborn figures is very difficult. So it's not so easy to modify what you have created with Seaborn. Okay, so with that, we have only one package left, which is Bokeh. But before we turn to Bokeh, I want to briefly have a look at saving figure. So here I have opened a new script in which I have recalled our matplotlib, pyplot, scatterplot commands again. And then at the bottom, I have added another command called save figure. And as a file name, I've here entered penguins.png. So I now don't only want to see the figure here above the console, but I want to have it as a file such that I can also send it to other people, for example. So rather than plot show, I'm ending my plotting command with save figure, and I'm providing a file name into which to save the figure. Okay, so I'm also being shown the plot here, and if I look into the directory in which I'm working, I see that there is a new file called penguins.png. So if I open this, it's a very small file. There are probably keyword arguments in save figure by which I also can control the dimensions of the picture, but you can notice that if I zoom in, this picture looks very pixely. And even if I change the resolution at some point, it would always look pixely. This is because PNG, or portable network graphics, is a bitmap format. Yeah, there's each image is saved according to its pixel-wise representation. So if you want to avoid pixelated images, if you zoom in very much, you need to use vector graphics. So the difference between bitmaps and vector graphics is that vector graphics don't save the image pixel by pixel, just listing the intensity or color at each pixel, but they rather save an instruction for recreating the image using simple geometric operations. Yeah. So whereas in the bitmap, the statement may be pixel at coordinates 90, 60 has color red. In a vector graphic, the instruction is starting from the origin of the image, move 80 pixels left and 70 pixels up, and then there draw a circle with radius 10, for example. Now, the good thing about vector graphics is that because they are not pixel-wise representation of the image, but instructions for recreating them, you can basically view them at any resolution without them becoming pixelated. So saving as a vector graphic is rather easy in Matplotlib. You can simply change the file extension of your file name to be SVG rather than PNG, which once again is for scalable vector graphics. So if I run this, I get another new file in my current directory. And on Windows, this file is typically not associated with the gallery, so it will not open in the gallery, but it will open in a browser. So if I now double click on this, I get this picture, and I can use my mouse wheel to zoom in and out. And you may notice that no matter how far I zoom in, this is the maximum zoom now, I think, I still see very nice round circles rather than edgy pixels. So this is the difference between vector graphics and bitmaps. Okay, so with that, I want to come to the last example of a package for plotting in Python, which is Bokeh. So I'm here starting my Bokeh script by importing the submodules plotting and models from Bokeh. I'm also loading Penguin dataset again. And then the first thing that I do is I simply create an empty figure and see what type it is. So it's a Bokeh plotting figure. And if we ask what kind of operations we can apply to this, there's a lot of things that we can apply to this. And one of the methods that we can apply is circle, which is supposedly for drawing circles into the empty figure. And this is what we will do next. So let me uncomment the next commands. So this is basically the equivalent to the scatterplot command in all the other packages. So we are once again supplying the column titles for what we want to have as our X and Y values. And then Bokeh does not work with data frames themselves, but it has to convert the data frame into a format that it can work with. And this is done using the columns data source function from the models submodule. So we are calling the columns data source function with the Penguins data frame, an input argument, and this will be the source for the scatter plot. Axis labels are then not modified by calling different functions as with the other packages, but by controlling attributes of the figure. Here, the x-axis and y-axis labels are set to different values. And then showing the figure simply works by calling the function show from the plotting submodule. Okay, so if I run this now, I don't get an output on my plotting panel in Spider, but instead it's opening in a browser, and we can see that there's now a plot of the same dataset that we already saw a couple of times before, but we can do several things with it. We can, for example, move this plot around. We can also zoom in. We can use the mouse wheel to zoom in and out. We can save the figure under a name, and we can reset to original value. So this is the type of output that you get from Bokeh. So here we were doing a scatter plot, and it's opening a few interactive features for interacting with the plot. And we want to add one more thing now, which is hover info. So we want to add more information to the individual data points. So in order to do this, you have to, in Bokeh, define a list. This is the list where each entry is a tuple of two entries, one corresponding to the name you want to give this information, and the other to access the columns of the data frame. So here, for whatever reasons, you have to access them with at and then the name of the column in the data frame. Okay, so if we have prepared this little dictionary-like list, we simply call the method add tools from the figure that we have created, and we then create hover tools using our hover info. This is the input argument to this function. And then we also need to show the function again. So this is now the second output from Bokeh, and at first glance, nothing has changed. But if we move across the data points, we can see that now we have hover info in the sense that when we are hovering over these data points, we are being shown the individual values and observations that they represent. Okay, you can also save Bokeh figures by defining file name or destination where to save it using the output file function from the plotting submodule. Here you specify the file name, as this is not just a graphical representation of a figure like a bitmap or a vector graphic, but it's an interactive web page. This is being saved as HTML code. And you also give it a title, and then you can use the save figure command. Let's try this out. So this time, obviously, we don't get the figure being shown in the browser because I've commented these lines. But if I look into the current folder, I now have an HTML file here, which I can again open in a browser, and it will show me the figure that I have created with all the interactive features. Okay, so this is the great advantage of the Bokeh package. It produces interactive features rather than it produces interactive figures rather than static figures that can open in a web browser and that you can send to people, colleagues, or friends. And this is very cool and impressive. However, Bokeh is not always easy to use, which you could have already sensed by looking at our very few basic commands. And it can result in some kind of messy and unreadable code if you want to add a lot of features. Okay, so this was it for data visualization. We have now worked ourselves through 2/3 of this section data analysis. So last week we were having a look at pandas. This week we were having a look at data visualization. And for homework, I want you to read this additional section on statistical models. And this will then allow you to also do the exercise, which is about loading the penguin dataset and applying a specific statistical model to it, and then visualizing the outputs from this model. Okay, so that was it for today. Thank you once again for listening, and take care and goodbye.